In this video, we are going to describe reactive programming. What is it? And most importantly, how does it compare to the other paradigms that you may be familiar with? So in the first section of this video, we're going to talk about procedural, object-oriented, declarative, functional, and reactive programming. So what do I mean by a paradigm? A programming paradigm rather, is basically just a way to classify programming languages based off of their features and how you go about thinking how to solve a problem using that language. And that's a really important concept, because a programming paradigm is not just necessarily what commands or functions or methods or whatever you have available to you in the language of your choice. A programming paradigm is a mindset. It's a way to kind of think about and approach a problem, and there's a handful of very popular different paradigms out there. Now, of course, the paradigm will affect what features will be available in a language, but it's very important to understand that to truly express yourself in a programming paradigm, you have to understand that actual paradigm and how to think in terms of that paradigm. Because, you can take an object-oriented language like C# and you can write procedural code. Not necessarily saying you should really have an object-oriented mindset, and that's kind of what I'm trying to express. But let's go ahead and just go down the list and define what I mean by these different paradigms. All right, the first paradigm I want to talk about is a paradigm that I'm sure all of you are familiar with, even if you don't know the name for it, and that is procedural programming. Procedural programming is basically just the idea that our programs are collections of functions, and that those functions get executed, when they get executed, it goes from top to bottom and just executes each line individually. Sort of the idea of this paradigm is that the computer, we're just giving instructions to the computer, line by line by line. Yeah, we might have some for loops or if statements or other control statements, sure, but at the end of the day, besides those simple imperative commands we can give the computer, the only other tool we have are functions. So an example of a procedural language would be C. Now, procedural programming has a couple of pros. For example, it's simple to write and it's easy to understand. So this is the style of programming everybody starts off with. And in fact, it's the style of programming that computer science started off with. I mean, assembly, machine language is practically just a procedural interpreter. And so, what's wrong with it? Obviously, we know that procedural programming has been sort of out of style for a very, very, very long time, except in things like performance critical code, driver code, kernels, and all that fun stuff. So what's wrong with simple, straightforward execution of commands? Well, it's very difficult to maintain. And it's difficult to maintain for a lot of reasons. We don't have a lot of abstractions here. We only have this one tool in our toolbox, the function, or the procedure, and that's it. So it makes our code very verbose, but it also makes it so we have to rely on global state all the time. It's very difficult to pass around all the things that we need functions to have access to when they execute. So as a result, we rely so heavily on global state. And the problem with global state is that anybody can change it. Any line of code can change your global state. So another con of this style is it's prone to very difficult bugs, because at this point, you might have your procedure that looks correct and might be correct, but it's reading values from some global state somewhere, and you totally forgot that 10 million lines away you had this one line of code that alters that global state in a way that makes it incompatible with that procedure, causing your correct, quote-unquote, procedure to fail. So there's a reason why we moved away as an industry from the style of programming. But, of course, there's a reason why this style of programming is the first style of programming anybody's going to learn, because it's so simple to write and easy to understand. All right, well, just like the industry, let's go ahead and move on to object-oriented programming. So the whole object-oriented paradigm is based around the concept of, well, an object. And what's an object? An object is a collection of state and behavior. But that is so important, because previously, when we were talking about procedural code, the biggest problem was global state, how different procedures manipulated global state, and that caused issues. And that causes issues for a variety of reasons, and object-oriented programming fixes that by localizing state and behavior to individual, hopefully small, objects that hopefully follow the single responsibility principle. So we have these small, well-defined objects that do one thing and one thing well, and then we can compose them and put them together in interesting ways and make code a lot simpler to understand. Although we have more tools, the language is a little bit more complex, but at the end of the day, the code ends up being much simpler to understand compared to procedural code. Yeah, I'm sure, we're all C# or Java or JavaScript developers here, so I don't necessarily have to talk a whole lot about object-oriented programming, but I do want to bring up my pro and con here, which is actually the same thing. And that is, the code is still imperative. So basically, when we have our objects, and we have object-oriented programming when we define our classes and instantiate our objects and all that fun stuff, but between the curly braces and our methods, we're still writing code imperatively. We're still writing instructions to the computer. We're telling the computer exactly what to do. And it's a pro because it's very easy to conceptualize, and it's very easy for a person who's only used to procedural code to jump into an object-oriented language, and they only have to learn classes and objects and all that fun stuff. Then once that's done, they can still look in between the curly brackets of the methods, and they see imperative code, line-by-line execution. And that's a pro because it's easy to conceptualize, but it's a con because, as you'll see in a moment, imperative execution of commands to the computer isn't necessarily the best way to go about solving a problem. It turns out if we add a little bit more abstraction and do a little bit more, we could actually make imperative code, or rather, we can change our imperative code to a different style that better describes what we want to do as opposed to necessarily how exactly to do it. And we're going to see that here in the next 3 slides. So let's move on to the other end of the abstraction spectrum and talk about declarative programming. Declarative programming is all about you describing what you want to have happen, but you not telling the computer how to do it. And we see 3 examples right here on this slide of declarative programming. We have SQL, we have my favorite write-only language, regex, and we have HTML. And all of these 3 things share a lot in common, even though they really might not look like it, but they share a lot in common. And the common thread is we are interacting with complex code or database engines or browsers, but we're doing so in a very simple, easy to understand, domain-specific format that describes what we want to have happen, but not how to do it. So in the case of SQL, we have this really simple thing that you might have written queries like this quite often, in fact. But when we execute that on a database engine, it goes out and does a whole bunch of stuff. Describing exactly how it's going to partition the data, index the data, retrieve the data, cluster the data, all that stuff. Database engines are very complex pieces of software, but we interact with them in such a simple language. And that's sort of the beauty of declarative programming. Take this regex. This regex parses postal codes. And if we were to write that exact same logic procedurally, it would be very long, but instead we've compacted it into this one line of mostly unreadable, to be honest, code that is something you only have to really write once and you can reuse from then that point forward in a very compact way. And that's a cool thing about regexes. And then we have, of course, HTML, where our browsers are very complex pieces of software, but we work with it, we interact with them in such a simple language. So I kind of like to think of declarative programming more like data than code. Now, that's not necessarily true, but that's kind of how I conceptualize it. We want to tell the computer what we want, not how to do it. So the pros are obviously the data is self-describing. We can take one look at it and we know exactly what's going on. Some declarative languages are easier to read and write than others, obviously. Yes, I'm looking at you. But yeah, it's very self-describing. And also, it's as powerful as the interpreter allows, or your language, or whatever thing you're interacting with your declarative code. And that's really awesome. Like I said with the SQL example, database engines are complex, but we interact with it so simply. Now, the cons, of course, is that it can be limiting. You're not going to write a game engine in SQL. That's not going to happen. I mean, I have seen some people write fractals in SQL, which is crazy, but still, you're limited by the language itself and what that language is being ran on. And that can be an issue with declarative programming. But what if we wanted to take this whole idea of being more explicit about what we want and not how we get it? What if we want to take that, but we wanted to apply it to a language like C# or JavaScript or even Java these days? How do we go about doing that? Well, there's another programming paradigm that actually falls under declarative programming, and it's called functional. So functional programming is a paradigm that's sort of seen a renaissance in the last 10 years. All major languages, with few exceptions, have incorporated functional ideas into them. And it's a very great paradigm to look at and understand and work with. And I'm sure that you guys have seen examples of functional programming being used today. It's become very popular. It's become very popular to mix object-oriented and functional styles. But if we were to talk about pure functional, the pure functional paradigm, what we would be describing is a language that has these functions that we use and we pass around and compose, and those functions do not alter state. They do not have any side effects, and they also, as a result, they become pure. And pure, simply defined as a function, will always return the same value given the same parameters. And there's a lot of different kind of features that fall under this functional paradigm, and not all those features are available in all languages that adopt these features. Like I said, it's more common to see a bit of a hybrid between object-oriented and functional code. In fact, what you can see right here on the screen is such a hybrid. This is just straight up JavaScript. And like declarative programming, we're just describing what we want to do. You don't see any loops. There aren't any loops. There aren't any array.pushes, or there aren't any if statements. I mean, we're literally just telling the computer what we want to have happen, but we're not describing to it how to make that happen. And that's kind of the idea, the kind of nebulous sort of concept of functional programming and declarative programming as a whole. So if you look at this code, we get customers, and that can return anything, an iterable of some sort. We filter out people that are equal to or under 21. We grab all of their addresses and concat all. Concat all, if you're familiar with C# or and LINQ, would be the select many operator. Then we map it. So we take all these addresses and we get the name property out of that address. And then we join all those addresses together with a comma. And then finally, we print them out. So between here and here, we don't have any side effects. Everything is pure, everything is functional. And then, of course, to display the data to the user, we have to step out and cause a side effect, in this case, logging out to the console. So pros, easy to reason about it. If you write, functional code can get very complex, but if you write it simply and work with it and start to understand it, it becomes very, very easy to reason about and look at a glance what exactly is going on, just like the example with SQL. Composition, again, we're not composing objects anymore, we're composing functions. Again, I'm repeating myself, but it's very, very expressive. It works great with object-oriented programming, as you can see with languages like JavaScript, C# or Java. And it has a basis in higher math. A lot of these concepts are borrowed from higher math. And so if you have a background in that sort of stuff, this should look very, very familiar, even if the syntax might be a little different. A lot of the terminology is borrowed. Cons are, you have to think differently. You can't just take an object-oriented mindset and start writing functional code. You have to change how you reason about logic. And we're finally getting to the point in this presentation where previously, I'm sure you guys were aware and comfortable with procedural, object-oriented, and declarative code as far as HTML and SQL. But finally, we're starting to talk about a shift in mindset. And that is what this video is all about. We have to learn to think differently. Now, I put that as a con because it might put people off who aren't willing to really invest the time to sort of internalize these concepts of functional programming. But in reality, it's kind of a pro because now we have an opportunity. We broke away from the imperative sort of way that we've been thinking about code for so long, and now we're thinking differently, and we can do a lot of awesome stuff. It's not always the best choice, you know, for certain very high performance scenarios. You might want to sort of break or bend the rules, and for architectural reasons, you might want to break or bend the rules. But that's usually fine because in mainstream languages, C#, JavaScript, and Java, don't really write pure functional code. We generally kind of mix it with a little bit of imperative code as well that causes side effects, and that's okay. And another con is it basis in higher math. So if you really haven't looked into these sort of concepts before, you might it might be even more foreign to you, and I put that as a con. But yeah, so we're right about to talk about the reactive paradigm, but I just wanted to sum up functional programming. It's basically just a declarative programming where we describe what we want to have happen, but not how to do that thing, and we can compose these functions and everything is awesome. So let's go ahead and move on and talk about reactive programming. Reactive programming is very, very similar to the declarative and functional paradigms that we previously discussed, but it has a very, very, very important distinction to it. And that distinction is that what we do is, instead of describing our data like what we do in functional programming, we describe our data in terms of other data that we compose and everything's fun. Instead of describing our data in terms of other data like that, we describe our data in terms of streams of events, streams of changes or timers or whatever. And we create a pipeline of that sort of thing so that when certain pieces of data change, that pipeline then gets processed, it goes through all of our manipulation, and it comes out the other end and it does something. What that something is obviously up to us. So let's talk about the simplest form of reactive programming that I'm sure all of you are familiar with, and that is spreadsheets. So spreadsheets are awesome. They were basically the killer app for as far as personal computers go. And here you see an example of Google Sheets, and I have a very simple formula set up right here on C2, on cell C2. And that is simply A2 plus B2. And we don't really think about it that much when we write these formulas. We simply describe what we want the data to be. We want C2 to be the sum of A2 and B2. But let's actually think about what happens behind the scenes. We have to create this sort of dependency graph or relationship between these cells so that when the data in one cell changes, the data in the final result gets changed as well according to the formula. Well, that's exactly what reactive programming is all about. Reactive programming is that we take these sources of data, we combine them, we compose them, we manipulate not the sources themselves, but the data they return, and then we do something with the value at the end of the pipeline. So here's an example of actual code from RxJS. And here what we do is we take the cell A2 and we take its value, we combine latest with cell B2, and then we map it to taking A2 plus B2, and we get a value. And so we've just described declaratively and reactively what we want this cell C2's value to be when it produces a result. And then, of course, at some point down the road, we subscribe to that value and we print it out to the console. And so by doing this, this code right here, literally, if the value of cell 2 or cell A2 or cell B2 changes at any point after the subscription, we will get a new value here in our subscribe as the result of adding those two cells together. And that is the core of reactive programming. We have the stream of events, the stream of data, and we want to create these pipelines to manipulate that data, combine the data, transform the data, so that at the end of it, we get something we can use. But it'll all automatically hook up to itself to where if any of the things that our pipeline depends on changes at any point, we get an updated value at the end of the pipeline. And that's it. That's the whole idea of reactive. Now, there's a couple other things we'll talk about in the next video, such as push versus pull, everything is database, and so in, and what exactly reactive extensions are. But I just wanted to talk about what reactive programming is in terms of all these other paradigms we've looked at. It's very declarative, but most importantly, it's all about manipulating streams of data as opposed to or transforming streams of data as opposed to transforming a list or a collection or something like that, something that's static that never changes. Because obviously, if this wasn't reactive, what we would have to do is we would have to add a callback on both cell A2 and cell B2 to say, okay, so if you ever change, we need to update this formula. Reactive programming is like that, but so declarative. We simply write out our operations, our pipelines, our event streams, and everything just works and gets wired up correctly. And that's really what's awesome about it. But there's a million other things we can obviously do with this style of programming. But for this example, I really just wanted to bring home the point that in a lot of ways, it's very similar to a spreadsheet. But with that, I think we'll end this video here, and we'll see you guys in the next one where we take a look at the core concepts of reactive programming. So we'll see you guys then.